Hello friends, I welcome you all to my channel. This video is part of the playlist Python Basics Beginner's Daily Dose, where I upload videos on the basics of Python programming language so that beginner level developers or programmers will get uh, will get to understand how Python works behind the scenes. Even though these concepts may not be used directly, but it's a good idea to know how it works. In this video, I will. This is part two of the part two video on iterators and iterables. If you have not seen part one, the previous video, I will highly recommend and request you to see that video first. In this video, I, I will try to implement a class that supports the iteration protocol. That means I will write a class that will implement the underscore underscore iter underscore underscore iterable protocol method so that we can use foreign statement to iterate over the values of the items of the class. So let's get started. Okay, so as stated in the previous video, I will try to implement a binary search tree, and I will implement the underscore underscore iter protocol so that by default you can iterate over the values of the binary search tree in order traversal fashion. And I will also write two separate other methods that will return an iterator to iterate the values of the binary search tree in post order and pre order. So let's start writing the code. I'm not a good coder, so definitely I will fumble and I will get stuck. So please bear with me, and there will obviously be lots of errors on the console. So uh, let's do it. So a class bs3 ret. Let me first write the constructor. Okay, none. I don't need all this thing. I okay. The way I will the underlying data structure to store the values of the binary search tree will be obviously it will have nodes. It will have nodes, and a node will be an array or list of three items. The first item will be the value of the node. The second item will be will be again a list, which is basically a node that will refer to the left subtree, and the third item of the list will be reference to the node to the that refers to the right subtree. So let's say uh, root uh, root is initially none. So in binary search tree, when it is empty, the root is usually null or void, or in Python it is none. It has no value, empty. Now let's we have to first define a insert method for inserting a value. So let's okay. So this this will be a little complex method. If we write it incorrectly, the whole binary search tree will be incorrectly constructed. So we have to be careful here. So now insert. What I will do is I will write a helper recursive function to insert the value in a subtree. So for the timing, let's pass it. Uh, I will write insert, let's say helper. I will take a node which basically here will be a list of three items. The first item is the value of the node. The second item is the will be the left subtree, which is again a list of 3 items. The third item will be the right subtree, which will again be a list of 3 items. So the value now, insert helper will return the root of the will return the subtree rooted at node after we have inserted the value in the subtree which is rooted at node. So in the insert method, what we do is we will assign the root to self dot insert helper, and what we need the root and the value. So this is how we recursively we invoke the function recursive function insert helper inside the inside the insert method. And so since insert helper insert helper inserts the value in the subtree rooted at node, and it returns the root of the subtree. So now let's implement the insert helper. Now, okay, so we have a node which is the root of a subtree, and we want to insert the value in that subtree, which is also a BS tree. So first we have to check what if a node is none. Obviously, if node is none, we will simply return a new node with the value. So if node is none, then we simply return a list, which is return a node which we are implementing as a list, where the first item will be the value, the second will be here none, because we are returning a node with only the value with and having no left child or right child. So none and none. So if node is none, we are simply returning a new node having the value which is being passed as an argument to this function, and with no and empty left and right child. By empty we are using none. Now, so node is now node is not, if what if node is not null? I mean it has some data. So so node is referring node is the root of a subtree. So first we will check if the value is less than the value of the node. Now how do we get the value of the node? It is the first item. So node 0. If this is the case, what we do is we have to recursively insert the value in the we have to recursively insert the value inside the left subtree of node. We have to okay, and I'm not using the pen tablet. It would have been better if I could have shown you diagrammatically how it works. But anyway, let me write the code and maybe you will understand. What I will do here is, if value is less than the value of the node, uh, then we will assign the left subtree as the insert helper node 1 value. So let me first complete the code. Else definitely means it is greater than equal to node 0. So the way we are building the boundary search tree is that all the values to the all the values for a specific node in the tree, all the values in the left subtree will be less than the value in the node, and all the value in the node to the in the right subtree of a node will be greater than or equal to. So here we will assign node 2, which is the right subtree of node, as insert helper node to value. And finally, we will return the node. Finally, we will return the node, because as we said, the insert helper will insert value in the node, and then it will return the node itself. So we are inserting value in a subtree, and we are returning the root of that subtree after the subtree has been modified. Now, if this is hard for you to understand, let me explain you further. So if value is less than node 0, means if value is less than the value in this node, then obviously we have to insert a value in the left subtree of node. The left subtree of node is node 1. So we are calling this function again, insert helper, passing the node 1, the left subtree of node, and the value. When we call this, what it returns? It returns the left subtree of node, which is node 1, after the value has been inserted in the left subtree, and that modified left subtree, we are assigning it to the left subtree of node. Similarly, we are doing it for the case when value is greater than the value in the node. We are inserting value to the right subtree of node, and that modified right subtree is being assigned to the right subtree of node, which is node 2. Now, insert helper. Okay, so insert is done. I'm not sure whether this is correct or not. It will work properly or not. Let's proceed. Now we define the iter, which will by default return an iterator for all the items in the BS in this binary search tree in order. So what we do is we will again use an helper recursive method. We will call iterator in order. We will take a node. Over here we will call okay, so the idea is, while we are traversing the BS tree in the in order fashion, we will collect all the values in the in order fashion and store them in a list. And from inside the underscore iter method, we will return an iterator of the list. We know that list in Python supports iteration, so we can either call iter on we can call iter passing the list as an argument, or we can directly invoke the list dot underscore iter. It will return an iterator of the list. We need to return an iterator from this underscore iter method. So let's say we take a temporary list value in order values which will contain all the values in the in order fashion, and we will store the values in the in order values, but finally what we will return is iter in order values. Alternatively, we could have also called in order values. We could have also called, this is the same, this thing and this thing are same. So now we need to put all the values in order fashion in the in order values. But let's first complete the recursive helper method, that is underscore iterator in order. Actually, this not this should not be called iterator. This should be called in order. We are doing an in order traversal on the BST and collecting all the values. So we need also to pass the in order values list. Now, okay. So we will process the node. What is node? Node is a root of a subtree. Since we are recursively traversing the BST, the binary search tree, at one point of time we will process the root of a subtree. So this node over here is the root of a subtree. We will only process node if it is not none. If node is not none, only we will process it. So in order, what is in order? We process the node. Sorry, what is in order? We first process the left subtree, we then process the node, and then we process the right subtree. So first we in order recursively call again the this method with the left subtree of node, which is node 1, and of course in order values. Now we will have to process the node. By processing node, what we will do, we will just put the value of the node inside the in order values, because in order values underscore values is the list where we are collecting all the values of the BS tree in the in order fashion. Over here, we just do append node 0 is the value of the node. Again, we call recursively the this method on the right subtree. So similarly, we will write two other recursive helper method for post order traversal and in order and pre order traversal. So let's say this is post order, and post order. In post order, what we do is we first process the left subtree, then the right subtree, and then the node. So this thing will be at the end. Now over here we must call post subtree. This will be post subtree and in order values. No, this will be post order values, and over here this will be post order values. Post order values. Similarly, we will have a pre-order. Pre-order recursive helper method for collecting all the values of the BS tree in pre-order fashion. So pre-order, and over here it will be this, and this. Recursive helper method is done. Now let's write the two method to the underscore iter underscore is the default method that will provide iteration support for iteration over the values of the BS tree in order fashion. Now let's write another two method. This will return an iterator. This will return an iterator to iterate the values of the BS tree in post order fashion. So over here we have to call iter underscore in order and in order values. And sorry, and we have to pass the root, and for post order we have to invoke post order with this post order array list, post order values. Similarly, we will write a pre-order method that will return an iterator to iterate the values of the BS tree in pre-order fashion. So pre-order this array, let's name it pre-order values, and this will be pre-order, and this will be pre-order, and over here we have to return the iterator of the post order values, and over here we have to return the iterator of the pre-order values. So this is the default iterator protocol method implementation that will return an iterator for iterating the values of the BS tree in order fashion. And these two are special methods that we have created for iterating the values of the BS tree in post order fashion and in pre-order fashion. And these are helper methods. I have no idea whether I've written the code correctly or not. It will work properly or not. I will just give a final check. Return iter okay. Pre-order is okay. Underscore. So in order is in order values. Okay. Post order, post pre-order. Okay. Now let's write the main function for testing this code out. Let's have a object of BS tree. Let's insert. Okay. I will test the code with this tree. Let's say we are inserting, let's say 5, let's say 5, let's say 3, let's say 4, let's say 5, and let's say 6. So the BS tree should look something like 5 will be the root, and after inserting 3 it will go to the left. So something like this, and when we insert 4, it will be something like this, and when we insert 1 when we insert 1, it will be when we insert 1, it will be something like this, and when we insert 6, it should be something like this. I think I have constructed the BS tree correctly. Let me check once again. 5 3 4 1 6, 5, then 3, then 4, 1 1 6. Okay. So now let's insert these values. Insert 5, 5, then we 4, then 1, then 6. Now when we do, let's print iterate to print BS tree in order for x in BS tree print x. So BS tree in order. Okay. Now we do the same for iterate to print BS tree. let's say post order, uh, we have to call post order to get an iterator from the base tree to iterate the values of the base tree in post order fashion. Similarly, we will do for uh, pre-order, and let's say pre-order, and we have to call here pre-order. BS3 in order, BS3 post order, pre-order, okay. 53416. Okay. Now this should print this should print 1 3 4 5 6. This should print in post order. So left subtree, right subtree, then the node, left subtree. Okay, left subtree. Then okay, so 1 4 3 left subtree, then 6. No, yeah, 6 and 5. And what about pre-order? Pre-order is a node, then left subtree, then right subtree. So first 5, the left subtree. Okay, so 3, 1 4, left subtree, then 6. I hope I am wrong. I am correct in printing the sequence of values for the 3 traversal order. Let's see what the code says. Let me now run the code. Python 3 BS3. BS3 in order is printing what is 1 3 4 5 6. 1 3 4 5 6. Okay. Post order is printing 1 4 3 6 5. Okay. Pre-order is printing what? Pre-order is printing 1 4 3 6 5. Why pre-order is printing the same thing like post order? Pre-order, pre-order, this pre-order. What is, oh, sorry, pre-order is we have to first process the node. And then the left subtree, and then the right subtree. Let me see now. 5 3 1 4 6. Yeah. So this was uh, a very this was to show how you can write custom class that supports iteration method. So I thought BS3 would be a nice example, even though please ignore the data structure I have used and the insert helper method, all those stuff. The primary objective was to demonstrate how to implement the underscore iter method and other special methods for special kind of different types of iteration. I hope I am right in the in implementing the post order, pre-order, or in order over here. All this thing. I hope I am right. If you think there is wrong somewhere, please let me know in the comment section. I will highly appreciate that. So with this, I end this video. If you found this video beneficial, then please like the video, share it with your friends, and support me by subscribing to the channel. And also do not forget to press the bell icon so that you will be notified by my future videos, as I will be uploading these kind of videos on basic Python programming regularly. And I hope this will never end, because the basic fundamental concepts of Python programming is huge. If you just go to the documentation website of Python, either tutorial section or library reference, it's huge. There is endless topic to discuss about, but I will try my best to cover as much as I can. So thanks for watching, and until the next video, take care and bye.